Happy New Year, everyone. In this video, we're going to be solving a nice problem, a 2025 special. So we have z to the power 2024 equals z bar, which is the complex conjugate of z. Z is a complex number and can be written as a plus bi, and a and b are real numbers, and I is the square root of -1. If you need a refresher or new to complex number, then you can go ahead and check out my lecture videos. Great. So let's go ahead and see how we can solve this problem, how we can approach it in more than one way. Since I said that z equals a plus bi is a complex number and z is in this equation and along with z bar, let's go ahead and quickly define z bar, which is the complex conjugate of z. So if z is equal to a plus bi, z bar is a minus bi. Okay? So when you add these and multiply those, you always get a real number. Okay? Now, and a plus bi is special for me because it's also the name of this channel, in case you didn't notice. So let's go ahead and replace z with a plus bi. And then a minus bi will replace z bar. And then we're going to go ahead and try to solve for a and b because our goal is to find z, right? Find all solutions. Now, to be able to solve a problem like this, one can use the binomial theorem. Even though it's not recommended, it's a method, okay? I mean, is that going to give you something reasonable? I don't think so, but here's how it goes. You can kind of expand this using the binomial theorem, which kind of goes like this, and choose 0, a to the n, and choose 1, a to the n minus 1b, so on and so forth. Use the combinatorial coefficient, so on and so forth. But guess what? This has 2025 terms, so who doesn't want to expand something like this, right? So instead, we can do the following. Since we have the conjugate of z on the right hand side, let's go ahead and multiply both sides by something. And what would that be? It would be a plus bi. And let me tell you why. If you multiply actually both sides by a plus bi, then you're going to get something nice. Because a plus bi and a minus bi are multiplied together, and that's going to give you a real number. What is so significant about getting a real number? I'll tell you in a little bit. But first, let's go ahead and add the exponents. 2024 plus 1. This is where the new year comes in. Yay. All right. I don't know if you heard it, but there were some fireworks anyways, because I'm kind of recording this around 12:41 a.m. And it's just going to publish in a little bit, in about, probably in less than 6 hours. Okay, so what is the product? From difference of two squares, we get a sum of two squares, which is kind of weird, but that's the truth. So now we get this equation. And this is, again, complicated. Yes, you can expand it with 2026 terms, even more, but that's just equal to a real number. You know what that means? The imaginary part is 0. So you can kind of put the imaginary parts together, but again, that's going to be horrific. It's going to be crazy, right? Insane. So let's not do it. But what else can we do? Well, we can first of all think about it this way. Can I take the 2025th root of both sides and get the answer? Well, yes and no. So if you take the 2025th root on both sides, you're going to get something that looks like this. The problem is, and of course we're kind of raising it to the power of 1 over 2025. The problem is a complex number has 2025th roots. Wow, there are so many. And we don't even know what a squared plus b squared is. If we can find out what it is, then we can talk about solutions, right? But one thing we know is that we're going to be looking at the roots of a real number, which is kind of easy to find. Make sense? Okay. Think about square roots of 4, 2, and -2. Of course, the 2025th roots are not going to be that straightforward, unfortunately, right? So we need to approach it a little differently. So my motivation is to find a squared plus b squared. How can I find it? Okay, if you know this, things would be a little easier. The absolute value of the absolute value of a plus bi is the square root of a squared plus b squared. So if I can find the absolute value of this number, then I can find the answer. But how do you find the absolute value of something like this? Easy. So you start with this, right? And then take the absolute value on both sides, right? And when you do, something to keep in mind. This power can be taken outside the absolute value. It's just a property when that's an integer or a real number maybe, right? And we're going to get the following. But these two numbers have the same absolute value. That's what's special about conjugates, because they're basically reflections. So this one is going to give me the same number on both sides, but one of them is raised to the power 2024. Okay, what is that supposed to mean? Just multiply both sides by square root of a squared plus b squared, and you're basically going to be increasing the exponent by 1. So it's going to be 2025, right? Now, this makes more sense. We have this, right, is equal to that. Okay, what does that mean? Now, I think I should call this something. How about r? Let's call this r. If I call this r, this will be r squared. So now we're going to get something like this. R to the power 2025 equals r squared. By the way, I didn't have to do this because I could also say r to the power 2024 equals r, right? And that would give me the same thing. Great. Now, we could probably proceed with this, which I don't think we need that. Forget about it. So now let's proceed with this. And again, forget about multiplying these things. Oops. Eraser doesn't stay with me. Okay. Oops. I don't know why it's not working. Here we go. And this is going to be 2024, and this is going to be that. Okay. Now, we can go ahead and call this r. And r to the power 2024 is going to be the same as r. Let's go ahead and put the r on the left-hand side. Set it equal to 0. Factor out an r. And now we get two things. R is equal to 0, or r to the power 2023 is equal to 1. Which means r is equal to 1 because r is a real number. It can only be 1 in this case. Don't worry about the 2023 roots. You're not looking for a complex solution. Okay? R equals 0 means z is equal to 0, because that's the only possibility. That's not that interesting, but z equals 0 is definitely a solution. Okay? What if r is equal to 1? Then we can just replace r with 1, right? And now we're going to get, let's get back here. R is 1, so this is 1. And then let's clean up this area so we can continue our work here. Now we have our complex number to the power, and I need to clean this up as well, right? This is equal to 1. And now we get z, or a plus bi. I should probably use z here. Z to the power 2025 equals 1. And guess what that means? We're looking at 2025th roots of unity. And how do you express that? Just replace 1 with e to the power 2 pi ni, and then raise both sides to the power 1 over 2025, or just divide the exponent by 2025. Now, if n is equal to 0, z equals 1 is going to be a solution, and that's indeed a solution. If n is equal to 1, then z is going to be e to the power 2 pi I over 2025. Guess what that's going to look like? It's going to look like this. Cosine 2 pi over 2025 plus I times sine 2 pi over 2025. That's basically one of the solutions, but there are 2025 solutions to this equation. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.